So this is what the unit looks like so far. We've got the battery installed, and of course all the cables locked down. It's bolted to the bottom here. I used some wood filler pieces because the battery box was originally made to handle a larger battery, and I had plans of maybe having a roll-up cable reel that, or just a little lengthy cable so that I could daisy chain with other batteries that go inside of there. I, after consulting with some other people, decided not to do it that way. Of course, the other thing is we've got the inverter bolted to the piece of wood, just small wood screws to keep it from shifting around. This piece of wood will then become the basis for the box, which goes around this, but I have to watch out for the fact that we need to have air circulation around a lot of this stuff. So when this thing is in the use mode, we could call it, we need to open up probably, at least two sides of the box so there isn't much of a heat buildup inside. What I'm doing to keep this topped off is I have an interface point right here with the onboard power system in this trailer. I manually check voltage just using this little thing that's velcroed to the wall. And of course we attach this in with an interface point. Now this is probably a 12 gauge cable. I'd have to double check. It can actually handle, a good solid 20 amps, no problem at all. And it will work for transferring and equalizing power between batteries as long as all those batteries are not in a lengthy discharge process. As long as they're freshly charged relatively frequently, let's say daily, like when the power system is plugged in, then you're going to be okay. So what's happening here in the summertime, we're not going to have a problem. This charge controller, of course, is it's blinking a little bit here because it's just starting to get dim outside and the panels are flat mounted. What I was running into was it was kind of overpowering the relatively small battery that's mounted in this trailer. I want to have some way of daisy chaining additional batteries and power systems. So this thing that's about 2 foot by 1.5 feet is basically the way we would cordlessly, off-gridly, right? We're still using a cord, use a regular worm drive skill saw, which I use to cut out the wood for this. So we know that it works. We know that it's going to function. I know I can cut big lumber using this type of a setup. And when we look at the cost and complexity of this, it's really not all that different from regular cordless power tools when we consider the fact that you don't get comparable power. And when you look at the total investment of having setups like this and then using power tools that are normally corded power tools, but they're also much less expensive than their cordless counterparts, a lot of it evens out. And when we're looking at the economy of running an off-grid operation, this actually does even out a little better than burning through NiCad batteries, let's say on the DeWalt 18-volt power tools. At the off-grid locations, we've actually been using up a lot of those DeWalt 18-volt batteries. This is just more robust wiring. It's a larger battery. Lead-acid batteries are much more resilient. And a system like this is going to outlast normal cordless power tools. But obviously what you lose is that convenient portability. So for my purposes, I'm probably just going to be using this when I'm using a power tool that requires much more power than you're just going to be able to get out of something that takes a portable battery. The other thing is we'll be adding more outlets here. I may be also adding a little readout board with a digital readout that tells me my battery voltage condition. If I want to daisy chain other batteries, one spot that is left relatively exposed enough to put additional attachment points in is the back of the inverter. Those great big brass, copper, metallic lugs on the back of the inverter gives me an attachment point without necessarily having to break into the battery box. It gives me something that's reachable. And I think we'll be working on that in the future as I continue to scale this little project up. The cool thing about getting it to this stage, where it's basically a 12-volt battery and an inverter, is I can start using it in its present form to continue construction on the rest of the project, which is sort of cool. Other additions are going to include other types of plug and power outlets, so that in the future, if I'm going to attach other devices, other power strips, other things like that, it's going to be a little bit more plug and play than undoing a bunch of bolts and cables and things like that. We're going to have an assortment of plugs that allow this thing to get plugged into other energy production and other energy consumption, and of course other energy storage, also known as batteries.